Hello everyone, welcome to my channel. So in this video, we will learn about binary search in data structure and algorithm. So binary search is one of the most popular searching algorithm used to search an element in a sorted array. So the first thing that is mandatory for the binary search is the array should be in the sorted form. So searching algorithm is basically used for finding an element position in a sorted array. So we can use this binary search to find a specific element in our sorted array. So we always search this element in the middle portion of the array. Okay, so binary search, you can say, is a search technique that basically works efficiently on sorted list or array. Is to search an element into some list using the binary search technique, we must ensure that the list is sorted. So let's start. Okay everyone, so I've just created a array and let me just add some values in it. So let me add 11 and here 15 refine, 26, 32, 45, 58, 61, 72, 79 and 98. Okay, so this is our array. So a few things I wanted to share with you regarding the binary searches. So binary search should and would always be performed in a sorted array. It should not be performed in an unsorted array. Okay, and we take binary search as we consider this array, this value we consider as low. Okay, or we can say it as start. Okay, or beginning. And just pardon with my handwriting. Okay, and we consider this value as end. Okay, or high. You can see why we consider it as low, because it starts from the very beginning. Sorting means it starts from the low to high. Okay, we scale it like this only: low, then higher, and then 15 is greater than 11, 26 is greater than 15, 32. So we consider the first index as low and the last index as end or high. Okay, and we consider a middle as mid. So how we calculate mid in binary search? We calculate it by low plus high divided by 2. So in our case it would be 0 plus 9 divided by 2 equal to 4.5. Okay, but we take it as precise value, so we consider 4 as our mid. So we consider 4 as mid. Okay, now let's suppose we have to search element 72. Okay, and I just one more thing in this binary search. So if we have to search for an element greater than the mid, then we will be doing it in the right side. Okay, if value is greater. But if the value is on the lower side of the mid, then we will consider it will be in the left hand side. Okay, and just a quick review what we have just learned. So in binary search we have a low, we have a high, and we have a mid, and based upon these three values we would search our element. So if the value is 72, we wanted to search in our sorted array, so it would be greater than mid, then we will be search it in the second half. Okay, we will be search in this half. If the value is smaller than the mid, then we will be search in first half. So let's start, and let me just write a small algorithm here. So we have taken low, we have taken high, and we have taken mid. Okay, now it would be our step 1. Step 2 would be while low is less than equal to high, we will enter in a loop if array of mid is equals to the search element, then we will return the location of mid. Okay, this one is first condition. Another condition would be else if array of mid is smaller than the low. Then low would be mid plus 1, else third condition would be high equal to mid minus 1. Okay, so in our case, array of mid equal to search element. So our mid is 43. Okay, first case fails here. 43 is not equal to 72. Okay, so now we goes to the second condition. Second condition is if array of mid. Okay, so we go to the second condition. It's not low, it is search element. Okay, okay, so step 1 would be low, high, and mid would be low plus high divide by 2. Okay, step 2 we start repeat while low less than equal to high. Okay, then mid would be low plus high divide by 2. If array of mid equals to search element, return mid, else if array of mid less than the search element, then we will increment low, we will change the value of low, else high equal to mid minus 1, and if the search element is not found, we will return minus 1. Okay, now in our case, first condition is false. Okay, the condition is 43 is not equal to 72. So we go to the second condition where we check if 43 is less than the search element. Yes, it is less than the search element. So now we will increment and change our value of low. Okay, so now low would be mid plus 1, and mid is 4. So 4 plus 1, low would be 5 now. High is as usual 9, and mid is also going to change. So 5 plus 9 equal to 14, and 14 divided by 2 is 7. So now mid is 7. Now mid would be here. Okay, now again we traverse back and we will check our conditions again. If array of mid equals to search, if yes, we will return the location. Now we can see array of mid is 7 and value of array of mid is 72. Okay, and 72 is equals to 72. So here we got our result, and we will return 7th index up here. Okay, so in this way we found our element. But let's suppose I wanted to search for the 79, not for the 72. Now in this case also my search fails. Now 72 is also less than 79, correct? Now my values are this one. So now my low would again be changed. Low would be 7 plus 1 equal to 8. Okay, and my high is as usual 9, and my mid would also be changed. 8 plus 9 equal to 17. So 17 divided by 2 equal to 8.5. So I precisely take 8 as my mid. And in the first condition, while loop, we see 8 less than 9. So we enters again in the loop. Now I see my mid is 8, and I can also see it matches the element. So it returns the 8th index. Okay. In any case, let's suppose I am going with the search element as 26 and my mid initially at 4, low at my 0, and high at my 9. Okay, so I am going with the search. If let me just see 26. Okay, 26 is on second index. Okay, if array of mid is my 43, if array of mid is equal to search element, I don't see 43 is not equal to search element. Okay, so 43 is not equal to search. Then we go to the second. 43 is less than 26. No, this condition is also false. My first condition is false. 43 is not equal to 26. Second is also false. Then I'm going to third. Now I will increment my high. High is mid minus 1. So my high would be 4 minus 1, 3. Okay, just let me just write up here. Low is 0, high is 3, and again my mid changes to 3 divided by 2, 1.5 equal to 1. I'll take precise value. Okay, now my mid is 1, and I'm again checking. My mid is 1, high is 3. So 15 is equal to 26. In this case, 15 is not equal to 26, but yes, second condition matches. 15 is less than 26, not equal, so it's less than. Okay, 15 matches less than 26. So my low will change. Low equal to mid plus 1. Mid is my 1, so my low would be 2, high would be 3, and my mid also changes. 5 divided by 2 equal to 2.5. So now my mid is 2 precisely. Now again checks if array of mid equals to elements. Yes, the search element is in second of index and my mid also matches. So I return my array of mid value as second index. So in this case my mid also matches, and I return the second index. Now coming back to the time complexity. So best case complexity or best time complexity would be the case, in binary search, best case occurs when, let's suppose, the element to search, I'm again going up my array, so I wanted to search for the 43. Okay, and my 43 is in mid. So the best case is when the element to search is found in the first comparison, when the first middle element itself is the element to be searched. So the best case time complexity in binary search would be big O of 1. Okay, so let me just write B would be big O of 1. Okay, or shall I write up here? Now coming back to the average case, so average case time complexity or the worst case time complexity is in binary search, the worst case occurs when we have to keep reducing the search. Like you see in these two cases, above two cases, I have to keep reducing the search on the left hand side when the element is smaller, and or the left hand side when the on the right hand side when the element is greater than the mid. So I have to keep reducing my search, I have to keep reducing till it has only one or two element left. So in that case, the time complexity would be big O of log n. In worst case also, average would be the same and worst would be same, big O of log n. Okay, so these are the time complexity for the binary search. We have just a moment. Okay, so we have seen the rough idea we have of binary search, we have seen the algo and how binary search works. Now let's just write a small program for binary search without recursion. In this video I'll be writing without recursion, only loop, and in next video I will be writing with the recursion. Okay, so let's just write a main method first. Okay, first thing we have to define our array. Eleven, 30, 15, 46, 78, 87, 89, 90, 95. Okay, so I have defined my array. Let's just complete it as 10 elements. Now I will be defining my low as 0 and my high as array dot length. Okay, and I'm just defining a method int binary search result data. It will take array low, high and search element. Search element I would take 78 or 89. Okay, okay. Now in case binary search result data equal to minus search, then element not found or not available, else in other case element found at index. So I will be returning that index. Okay, now I'll start my loop while low less than high, and our mid would be low plus high divided by 2. Now my search, if array of equals to search element, then I will be returning my mid, else if array of mid less than search element, then I will be low equal to mid plus 1, else high equal to mid minus 1. Okay, so now let's just run this program. So we found our index we found our element at index 6, element found at index. Now we can see 89 is at 0, 1, 2, 3, 4, 5, 6 index. Let's suppose I'm going for the 190, that doesn't exist in my array. Search, and it would return with element not found or not available. So in this way we can search for any element using the binary search algorithm. And I think that's all for today, guys. Thank you. If you have any question or query regarding binary search, do comment and I would be happy to help. Thank you.